Hey everyone, I'm building an entire first-person shooter game from scratch in the Godot engine and documenting the progress with these tutorials. In this video, we're adding a basic Raycast shooting mechanic to our FPS controller. The basic FPS controller project from episode 1 is available for free on GitHub, and if you would like to download all of the source files, you can get access by joining my Patreon. Let's dive in. All right, so it's been a long time coming. We're finally going to be adding shooting to our first-person shooter game. It's not going to be as hard as you think. There are a few different ways you can do shooting in a game. The two largest ones are going to be called Raycasting or hit scan and a more physics-based projectile setup. All right, we're going to be focusing on a Raycast technique for this tutorial just to get started. The physics one is a little bit more complicated. So it's a lot more complicated. The Raycast is actually pretty simple, and you can get it going without a whole lot of work, and you've got a shooting mechanic in your game that you can just use and test and build from. I'm working from the last episode. Again, if you want to grab the source files for this, you can get that on my Patreon. Although you should be able to just plug this in if you've got your own controller, your own weapon setup. It's very modular and really not that complicated. The first thing that we need to do is get an input because we need to be able to test how we're going to shoot, right? So typically you're going to be shooting with the left mouse button. So we're going to adding a new input to our project. We go to Project, Project Settings, Input Map, and I've got all of my existing inputs. We're going to add a new action, and we're going to call this attack. You can call it shoot if you only have shooting. In my case, we might be adding melee weapons in the future, so we'll have it be attack. We'll add that, and then we're going to press this add button, and we're going to make it listen to the left mouse button. We add that in, and we're all set, and we close. Okay, now that we've got our input set up, let's test it, right? We need to actually check if we're pressing this input. Now, I'm going to do this in my idle player state script. Now, eventually, we'll probably move this into a weapon state machine or something a little bit more complicated. We're just testing today. So we're going to add this into our idle player state. You could be adding it into a first-person controller or anything like that. And how we're going to do that is the same way that we're doing all of these inputs right here. So we're doing an if input is action just pressed, and then we're going to check for that action. So we can actually just copy this, paste that in there. Or actually, let's put it down below. I like to organize a little bit. And we're going to do is action just pressed, and we're going to do our attack. That's going to pop up. We don't need is on floor. We can get rid of that, and we're not going to transition to a new state, so we can get rid of that. And let's just print you attacked. Good for you. All right, we'll save that. All right, so now when we're in our idle state, we'll press our attack button, and we should see a you attacked in our output. So let's check that real quick. We've got our controller. We'll press our mouse button, and there we go. We have you attacked. So we have our input. It's very easy to set those up. And now that we have our input, we can do our Raycast. Now the idea for this is when we press our attack, we're going to run a function that's going to fire a ray, and then we'll check if we hit anything. That's kind of the basic premise. So to create that function, we're going to head to our catch-all, be-all weapon script. And I promise we're gonna clean the script up, because it's getting a little clunky. All right, so we're going to create a function for our Raycast. We're going to call this function attack. We'll void that. And there's a few things that you need when you are going to create a Raycast. You need a space to do that Raycast in. In this case, we're going to be doing it from the camera. You need an origin point for that ray. You need an endpoint for that ray. And when you have all of those things, you check if that ray hits anything and you get a result. And that result is going to tell us at what point, what position in our world we've hit something. In our case, our origin point is going to come from our camera. So we need to get a reference to our camera. So we'll create variable camera, and then now in this project, we have a reference to that within our global singleton script. So we get a reference to our player, and then within our player, we have a reference to our camera controller. Now, if you're in your own project, you might have to get the camera in your own way, and that's totally fine. Just as long as you get a reference to your camera 3D node, you're good to go. So we have our camera reference. The next thing we need to do is get a space state. This is going to tell the Raycast in what world space it's operating in. Now, we want it to operate within the 3D world space of our camera. So we get our camera reference, and then we use the function get world 3D. And then our property will be the direct space state. Now we have our space states. We need to get our origin point for our Raycast. Again, remember we need our beginning point for that ray, and we need an end point for that ray. In fact, let's go ahead and comment this out real quick. Let's go back to run our game. Our origin point is actually that cursor right there. That is set to the center of our screen, and it's not going to come from the gun because the gun is weirdly positioned and rotated, and it's going to move around. For the player, it's going to be in that cursor. So what we really need is the center of our screen. Now, in order to get the center of our screen, it's actually very easy. We're going to need a variable for our screen center, and it's going to equal the result of a function get viewport and then size divided by 2. So if our viewport, our screen, is 920 by 1080, it's going to take 920, 1080 divided by 2, you get right in the middle. All right, let's go ahead and actually, let's test that out. Proof of concept. Let's print the center of our screen, and we have our attack. And now we can actually go back into our idle player state. Let's get rid of this little print and get a reference to our weapon, and let's run our, oh, I need to actually save that for it to show up. Let's run our attack function, okay? So now when we run this, we'll click our left mouse button, and we should get the center position of our screen. And there we go. So I'm running in 1280, 720. So the center of our screen is 640, 360. Perfect. Now it's not going to change. Even if I move around, we still have the center of our screen. Accuracy we'll get into later, and we'll do that in a different way. Basically, we want it to come from the center. We don't want it to come from somewhere else. Okay, so we have our screen center. Now we need to get our origin point for our array. To do that, we create a new variable, origin, and we set that to equal camera and project ray origin. Makes sense, right? And then we need a vector2 for that function, and we will use our screen center. And that's going to take a point from our camera space and become the origin for our array. So we have our origin. Next thing we need is our endpoint. So we create another variable, and that's going to equal our origin point, plus our camera project ray normal. Now, a normal is a direction, right? It's a direction. Usually you talk about meshes or vertices. So we're getting a direction from our origin point. Again, we're going to use the screen center for our vector2, and then we're going to multiply it by a distance. And in this case, let's do 1,000. So that's the distance that ray is going to go. So we have our origin point, we have our endpoint. Now we're ready to run our query. So we create a new variable. And that's not how you spell query. And here's where we do our ray magic. So we're going to use physics ray query parameters 3D. So this is a built-in that we can use to create a new raycast. And what we need is a from point and a to point. And we've created those. We've created our origin and our end. Now within this query, we want to make sure that we can collide with static bodies or physics bodies. So we need to set that parameter within our query. So we get our query, and then we do collide with bodies. You can also do collide with areas. You can also set a collision mask and do everything that you would typically do with collisions. In this case, let's just do collide with bodies, and we'll set that to true. And then the final step to do this raycast is we need a result. So we create another variable for result, and that's going to equal our space state, and then we'll do the function intersect ray. Now you can also, if you go back, you can also intersect point or shape even. Now if you had something really, really large, you might do a shape, maybe a grenade or a rocket launcher or something like that. In this case, we're going to do intersect ray. And then for our parameter, we need our query parameters that we just created. And there we go. Now we can actually test this. So let's do a print of that result. Now, instead of us printing you attacked, we should get information about what this ray is hitting within our scene. And again, this is only going to work if we're idle because I haven't included it with any other states. So let's go ahead and click. And you'll notice down there in our output, we have a position, we have a normal, a phase index, a collider ID, collider of what you're actually hitting, the shape, and the RID. So that's a lot of information already. And we're just clicking a button, shooting a ray from the center of our camera, and we already know where it stops, what it's hitting, and that's enough information for what we need to do. So let's get out of that. So let's add a mesh for where we are colliding with something, right? This will act as it could be like a bullet hole. You could even do a bullet hole if you have one ready to go and set up that as a decal or something. So we'll keep that there, and let's create a new scene. Let's do that. We'll go, I don't know why I have a scenes folder. There's nothing in there. Let's move that. All right, let's create a new scene. This will be a 3D scene. Oops, actually, no, let's do, don't save it. All right, let's add other node, mesh instance 3D. Let's do a sphere, and we'll make this material, let's just make it red. A nice solid, oh, that's not how you do that, is it? There we go. Let's make it red, and shading to unshaded, so it's just solid. Let's go check that out. Beautiful. That looks pretty boring, but that's fine. All right, let's make it small enough that it won't look super, super weird. And let's save this scene as a Raycast test. All right, so the idea will be to spawn that scene wherever we hit in our Raycast. And we already have our position, so it's really going to be pretty easy to do. So in order to spawn or instantiate our scene, we need to load it. So let's load it. And we'll add a variable, and we'll call this Raycast test equals preload. We'll preload it, and there's our Raycast test scene. We'll select that, and then down here, let's make it a little bit cleaner. Let's create a new function, and we'll call this test Raycast, and we'll use a position for a parameter because we're going to pass the position of our Raycast test result to this function, and void it because we're not returning any values. And let's create our instance. So we'll run this function. We'll do our variable instance, and then let's get our Raycast scene, and then we're going to instantiate. Now, if you're not using 4 or anything, I think it's anything 4 up, it's going to be called something different. It's not instantiate. It's probably instance, if I remember right. I might be wrong. But in 4, it's instantiate. So this creates an instance of that scene that we've loaded. And now that we have that instance, we add child, and we add that instance. Okay, now that we have that instance, we can set the global position to equal our position parameter. After that, we'll wait, let's say 3 seconds. Now you can set a timer within GDScript this way. This is a little bonus tip for you. So you do await get tree, create timer, and then set the number of seconds within your parameters, and then timeout. So now we have a timer for 3 seconds, and after 3 seconds, let's destroy our instance because we don't want thousands of red spheres everywhere for no reason. All right, so we have our test raycast, so let's run that function in our attack function, and then we'll pass our position. To get that position, what we need to do is take the result, get, and then our key. Now our key is, as we, let me actually bring that up again. So each one of these within a quotes is a key. Just a name within that dictionary of that information. So we need position. And so we'll get our key, position, and I think we're good. Now, there's going to be an issue. I won't fix it yet. I'll show you by running. So let's run our scene. All right. So we have 2 issues. The first issue is where we're adding our little sphere, and our second issue is we have an error. So the first problem, the reason for the error, we're running our test raycast function and using our result get position. Well, what happens if we don't have a result because we didn't hit anything? We end up with nothing, and it's going to be confused. It won't work. So we add an if statement, if result. So if our result variable is not empty or nothing, then we run our test raycast function. The second issue is we're adding the child to our weapon, which means it's going to move with our weapon. So what we need to do is get the root of our scene, and let's add the child to that instead. So let's test that instead and see what we get. Well, let's first test we didn't shoot anything. All right, we're okay. We're not getting any more errors. Now let's test our raycast. Much better. We've set up a raycast from our weapon, and really from the middle point of the screen there. And whenever we click our attack button, we're firing that ray, finding out where we hit, what we collide with. And in some cases, for example, this does not have a collision. So if I shoot at it, it's going to go right through. You see that? Because we're actually going to end up colliding with the floor, which has a collider. Now, these have a collision box, and so it collides. And that's a basic setup for a raycast. Now that we have an attack, we do a raycast when we attack, we know where we hit. So now we have this information and we can make it a little bit more like a gun going forward. All right, guys, if this tutorial was helpful, consider a like and subscribe to the channel, as we're going to be covering a lot more. Thanks to all of my patrons who keep this series going. You too can get access to the project source files by joining my Patreon. You can download everything there, and you'll also get early access to my videos and sneak peeks at future tutorials. Thanks for watching, and as always, keep creating.